Thanks, everybody, and welcome back. I hope the Kubernetes hate has left the room so that we can have a neutral perspective on the next 30 minutes. I will share our approach to monitoring Kubernetes with Icinga. People being here last year will remember some of the words I'm saying, since I want to tell a story of how we got where we are. But in the demo, there will be a little bit new stuff, so that will be fine. Yeah, my name is Eric. I'm responsible for the technological stuff at Icinga. In the recent past, with the Kubernetes module and our Go libraries, since lots of the stuff we have in Icinga DB is reused in Icinga Kubernetes or Icinga for Kubernetes, since we're also using a database for synchronizing stuff, and we had to pull out code we had in Icinga DB, make it a library in order to have it ready for Icinga for Kubernetes. Before I go into detail of our approach, I want to go back a little bit, as well as Chris did in the morning, with a history of monitoring. So how we started before we had before containers became popular, and before we had Kubernetes, or orchestrated container deployments. We had bare metal servers with hosts, right, physical, then later also with virtual machines on it. And also we can monitor cloud instances to some extent as well, of course. And then we have services, right? We have ping checks, we have application checks, resource usage, whatever. So all this is basic stuff, you know, and this is what's here in the industry since years. And with Director, there's also a part to automate all that stuff, and it also makes it possible to import or to monitor cloud instances with the AWS or Azure or vSphere module we have, so that you can have your infrastructure that you have on-prem monitored, and also cloud instances monitored with Icinga. And what we have with traditional monitoring is we have logs, of course. We have check plugins, and check plugins give metrics and give state. And with check plugins, we get alerts, so pretty easy. And in traditional monitoring, check plugins are the most crucial part, since without check plugins, well, there wouldn't be no monitoring. All the tools we have are built around using check plugins. You can build your own, you can use stuff. There are so many plugins out there, and they all share a certain functionality, which is they have a logic, how to gather and also interpret data. So a check ping does a ping, a check MySQL knows how to connect to MySQL and check MySQL. And there's a built-in common understanding of what is wrong, which has evolved over the years. And there are reasonable defaults implemented for thresholds. So you would just use check plugins and they will work out of the box. So you install like check MySQL, and then you get your alerts for free, since the plugin does all that stuff for you. And in addition to that, of course, it reports state. It has a text output telling you what is wrong, and it also gives you metrics. Now, with Kubernetes, the picture is a little bit broader. I won't go into detail, but it's more than hosts and services, right? So this stuff gets a little bit more complicated. So Kubernetes has loads of resource types, workloads, deployments, pods, whatever, you know, all that stuff. There's multiple components and layers involved in Kubernetes, and there are so many moving parts, and you have so many different failure points, what could go wrong. And you would need to have always an entire understanding of the whole Kubernetes stack in order to resolve problems, or in order to find the root cause of a problem, since Kubernetes is not really telling you always why exactly something is failing. So you have to go through the information Kubernetes provides, and you find that over certain places. And now you could think, okay, we have loads of resource types, which in the end represent applications. And of course, Kubernetes runs on a server, so you still have hosts. is that possible with hosts, services, and check plugins? So is it possible to transform the Kubernetes architecture into a host service model? I would say not. And that's also not our approach, how we do it, but I share that later. There's also the challenge of that, of course, in Kubernetes, pods come and go for whatever reason. So stuff you have, information you have is gone when the pod is gone. For example, a job or a cron job deploys containers. If you have scaling in place, then you will have pods coming up and down. And of course, also if you have deployments, replica sets, whatever. Kubernetes always tries to be smart and get your application running. And in order to do that, it will restart, kill, delete pods whenever it is necessary. So it's a challenge to get historical information in the correct sense, since A, it is lost, so we have to save it, and B, always the names change, so you have to get a correlation between that afterwards. So going to Kubernetes monitoring, what would you need to monitor? Of course, the infrastructure, the nodes where Kubernetes runs has to be monitored, of course. And then the Kubernetes components, or the components Kubernetes consists of, have to be monitored. Scheduler, etcd, API server, controller, whatever, lots of components. And then the resources, deployments, stateful sets, daemon sets, pods and containers, of course. And then also the applications running on the infrastructure. And our first versions, I would say, will focus on the first 4 things and not on the applications. So we will have monitoring for Kubernetes itself and the nodes it runs on. So when something fails, we will see that in Icinga, but we will not have something out of the box in the near future which will monitor applications. You could still, if you know it's a MySQL pod, you can still do a check MySQL, of course, but there's other tools you would use. But since it's early stage, of course, we're thinking about how to also implement application monitoring right out of our Kubernetes monitoring. So one thing, we heard it, probes, right? Just one slide. Use probes. They're not that bad as told, so sometimes they're good, or often they're good if they're correctly implemented. So that is something which Kubernetes provides you out of the box, which is a little bit of monitoring implemented that can be used in order to get your pods or applications restarted in the right sense. So how would you implement Kubernetes monitoring when it is not a host service model? I mean, we could do it, right? We have director with director import source. So we could, for example, write a module which pulls the Kubernetes APIs for all the resources it knows, and then somehow translate stuff into a host and service model, will be created as Icinga configuration, have some certain check plugins, then deploy the configuration, and Icinga will have some kind of Kubernetes monitoring. But since pods and stuff comes and goes so fast, this makes no sense, since Icinga would have to be constantly restarted in order to apply all the changes which happen in Kubernetes to be reflected in Icinga. So that is something we don't do. We could pull Kubernetes APIs, as I said. Kubernetes itself has all information available all the time, since in etcd everything is available, even states for certain resources. We could build something which deploys as an agent per daemon set or per pod. And of course, we would have to look at all the events happening in Kubernetes, whether they are warning or critical events, and also go through logs from containers if there's something interesting or something worth to correlate in order to determine a failure state of a certain resource. And of course, we would need metrics, since Kubernetes is all about metrics, right? There's no There's no check plugins per se. There's just some key values which are emitted. Kubernetes itself brings some metrics out of the box via the slash metrics API endpoint, but most of the time people, of course, are using Prometheus since this is the de facto standard. And I would say, is there anybody who uses Kubernetes not using Prometheus? I don't think so, right? So are you all using Prometheus for monitoring your Kubernetes? Or are you using something else like, I don't know, out-of-the-box stuff from Rancher, Portainer? No, only Prometheus alerts. Yeah, cool. Okay. I would say the problem with that is that in contrast to check plugins, where we have a common sense, where we have an understanding of how things should work, with metrics you don't have that, since there are a lot of them, and you have to, each and every one has to find out which metrics are relevant, are important, and which metrics reflect a certain state. And then those has to be implemented as a PromQL query, of course, and then we get alerts. Yes, there are resources where, I don't know, common PromQL queries are shared, so that you get a base level of alerts, but still, there's so many metrics, and you would have to understand so much that's not possible for each and every one to do, I would say. And also there are metrics, of course, on every level, from container up to the cluster, and you would have to find out when it's a problem. On the cluster level, maybe the metric is not a problem, but in a deployment, maybe it is a problem. So when it comes to determining the health state of a Kubernetes resource, and to make it easy, we are also using the Icinga states for Kubernetes resources, so okay, warning, critical, pending, unknown, whatever. And we try to, from the information Kubernetes provides, we try to determine the health. And that is composed out of, one thing is the expectations. So for example, if you have a replica set, you say you want to have 5 replicas, then you expect that 5 replicas are running. And then we can combine that with how many replicas are actually running. But also, we would have to include metrics there as well, since maybe everything is running, but some metrics are reaching certain thresholds, so we want to get an alarm, but for Kubernetes, everything is fine. And also, Kubernetes provides stuff out of the box like conditions and resource states, which can be used in order to get a health. Just to, I don't know, it's like for a pod, in our case, without metrics, to determine a Icinga state, I would say it's 400 lines of code with certain if conditions. So if that, then maybe that, else, whatever. So Kubernetes itself doesn't tell you that's the problem, but we have to go through the failing containers and look what's the problem there in order to have a output on the pod why it's not running or why it's critical. So what we do is we collect all the resources, and we have a Go daemon for that, which does that. And we're collecting them from the Kubernetes APIs and using Go, and since Kubernetes is written in Go, they're pretty good libraries, right? And also kubectl, for example, or other CLI tools all share the same library code, and we are also using that. And that's pretty cool, since you have, the one thing is you list all resources there are in Kubernetes. Then we synchronize that with the database. So our database is the, let's say, source of truth for us, what the current state in Kubernetes is. And since we're calculating stuff around that, we write that in the database as well, so that when users are accessing the web front end, that it's not issued to Kubernetes APIs all the time, but only a query against our database. This is a model we do with all our components, I would say. So first we list all resources in Kubernetes, synchronize that with the database, and after that we subscribe to only changes. It's also a feature of the Go libraries. And then we only update all the stuff which is happening. So if a new pod comes, we insert it into the database. If it gets deleted, we delete it, and that's like immediate. It's an immediate operation we get from the Kubernetes API. And what we do is we do that for all resources there are, so all the sets, all the deployments, all the pods, all nodes, namespaces, volumes, whatever you name it. And then we try to get an opinionated Icinga state. So we think that if stuff happens and if certain failure conditions are there, then we switch to warning or critical or whatever, and we see that in a demo later on. And of course, it's the same UI layer in all our modules. So we have like list and detail views, and we want to visualize Kubernetes resources and their hierarchies. Since monitoring Kubernetes is only good if the users of that don't have to understand the whole complexity of Kubernetes. Else it wouldn't make sense. If you would have to learn all the stuff and really know exactly what is going on from all versions, since there are also changes and there are new conditions and it's evolving. So it's also hard to keep up. The complexity should be reduced using a monitoring tool, and that is what we are trying to do in order to, with all the correlation we do, that we just give a simple string explaining why something is wrong. And of course, we also gather logs and events. We also gather metrics in order to have some nice little graphs for CPU, memory, storage, network usage. And later on, we will also try to use metrics in order to build alerts out of that, but not with the Prometheus Alert Manager. So yeah, as I said, we have a daemon in Go, and this Go daemon can run anywhere, so inside or outside a Kubernetes cluster. And it writes its state into a database, which is accessed by a web front end in Icinga Web, of course written in PHP. The deploy options are either via packages, so for all operating systems we have packages for Icinga for Kubernetes and Icinga for Kubernetes Web. We have, of course, containers, since we are also having a Helm chart for installing a whole Icinga stack in Kubernetes. This will also install Icinga 2, Icinga DB, and all the stuff we have. So there's some preparation or some work needed in order to separate the charts, but right now it will install a whole Icinga stack. In the future, you could choose only Helm install Icinga for Kubernetes instead of installing the whole stack. But you could deploy a ready-to-use Kubernetes monitoring, with that Helm chart quite easily. Okay, now I'm going to show it. See if that works. Can you read it in the back? No? Thought so. Better? Yeah, okay. So yeah, we released the first version 0.1 in May this year, I think. Somebody used that already? Yeah, 1, 2, yeah, really? Okay, cool, yeah, nice, good. Okay, as you can see from the menu here, there's lots of Kubernetes resources, of course, we're synchronizing, and as you might guess, this is something you know from monitoring, like Icinga hosts and services. You have the subject and the state, and a plugin output, and some additional information, and then we can go into a detail area, and then we have all the information of that node available with all labels, annotations, conditions, events, and the last YAML configuration, for example. So everything you would get from combining certain kubectl commands, you'll get right out of the box. And that's also, it's no magic that we're doing anything other than you would do with doing kubectl, get pods, describe pod, get logs, whatever. So this is basically all the information you would get from CLI commands as well. You will also get with the Icinga for Kubernetes, but you don't have to run those commands. You would just see all the stuff. Then maybe we go to pods, since I deployed some failing stuff. For example, a app with bad liveness. So I have a bad liveness check configured here. And instead having to look at conditions or at the reason why a container has failed, the pod is switched to critical since it has been restarted a whole lot of times with crash loop backoff. And that's what we are trying to do with all resources. Replica sets here, for example, it's a little bit lame since I don't have failing replica sets. But then I would see if no replicas are available, for example, then the replica set would be critical. If there are only certain replica sets available, it would be warning. And you can navigate through the resources from, let's say, top to bottom. There's no cluster view at the moment, so we start by deployment. And we go for, I don't know, only have one pod over there. Maybe here, Icinga Kubernetes. Have a deployment. A deployment has replica sets. So right here, I can go to the replica sets. If I go to the replica set, I can get back to the pods running the replica set. So that is like a drill down from the Kubernetes resource hierarchy in the module or in the front end. So I can get where I want to go. And also, of course, a pod has containers, and a container has logs. So everything, you get everything right out of the box, I would say. So, any questions? Maybe so far? No? Yeah, you, please. Since I would quit the demo, maybe you say, I want to see stuff. Wait a moment, you need a microphone, sorry.
Here you go. All this information that we saw, it just saved, how to say, permanently in the database?
Yeah.
And I can read it after half of a year, for example?
History-wise, will be implemented, but that will become on the next slide. No,
okay.
At the moment, only the current state is reflected. Since if Kubernetes emits the event to delete a pod, we will delete it from the database. If we would implement history, then we wouldn't delete the database, but mark it as deleted, for example, so that it will stay in the database. But that's nothing for, it's not implemented yet, but it will come, so that we have a history, correlation, see what happened back then, all that stuff. Yeah, definitely part of that. And this, I don't know, I got a question why we're doing that. So in the discussions before, why is it exactly this way? As you might have seen, there's no relation to Icinga 2 at all. So there's no hosts, no services. It would have been impossible to implement that in a other component, since it must be possible to run inside Kubernetes. So there's this code is only valid for Kubernetes, and it is a domain-specific daemon, which is responsible for only synchronizing Kubernetes data. So that's why the daemon part is a separate component, and all our stuff we do, we put it in separate databases. So that is, I don't know, a political or developer or whatever decision we made, that everything we have is in separate databases for concerns. Maybe you run it on different clusters, different backup strategies, whatever. So there's no central Icinga database having all the tables from all the modules. So Director has its own database, Icinga Web has its own database, IcingaDB has its own database. So that's why Kubernetes, or Icinga for Kubernetes, also has its own database. Since maybe you're just using Icinga for Kubernetes and have it running in Kubernetes, and don't use IcingaDB, Icinga 2, whatever at all. And for the web part, of course, this is what we do since years. If there's new features we want to do, it will be implemented as a module. Okay, there we have some links, but so yeah, code is on GitHub. We will have the version 0.2 next week. It will include then some metric charts already. Unfortunately, I can't show it since it's not merged, but next week we'll have that. And at the end of June, we will have a next release. Hopefully, since Johannes and the team for developing Icinga notifications will release Icinga notifications, so that it's one part missing at the moment. It's that we're actually providing alerts. So out of the information we have in Kubernetes, we can determine Icinga states. So, okay, warning critical, whatever. And then you may want to get notified. But without a host and service, it's impossible to get notified in Icinga. So all the functionality around notifications only works if you have a host or a service. So we could, of course, have a dummy host, like we do it with the business process module, if you know, that you have a dummy host in Icinga, and then use that in order to send notifications, but that makes no sense, since we're also shifting our approach there as well. Since we have modules responsible for only specific parts that are not related to hosts and services, they also want to do notifications. Business process, of course, they're somehow related to hosts and services. Our certificate monitoring, for example, vSphere-DB, for example, and now Icinga for Kubernetes, they all can send notifications without cheating at the moment, and the upcoming Icinga notifications will solve that, where we move the notification feature out of Icinga into a new component, and Icinga for Kubernetes will be the first client using it. Yeah, then we have a little stuff going on to refine the UI a little bit. Charts will be coming, also a little trend charts in the list views, and some other stuff. And if I'm not mistaken, that will be it for the next versions. And for the future, there's so much, I don't know, stuff to do. History, for example, cluster views, so multi-cluster support. Providing or configuring alerts in Icinga for Kubernetes. I can imagine that we provide an opinionated view on metrics, so that we say there are certain key metrics which are important, and that you use that in rules in Icinga for Kubernetes to configure alert rules, combine that with state. We determine out of the information in Kubernetes, have some, I don't know, thresholds, rules, combinations, whatever. And if then that evaluates to true, a notification will be sent to Icinga notifications. But it would be great if there would be input on that, since for me it's also hard to find out what are common base metrics we should implement and provide right out of the box. Since my idea is not that crazy as check plugins, since there are many check plugins, but to have a base level monitoring of Kubernetes right out of the box without having to configure loads of rules so that it makes sense. And if you're all using Prometheus and have your alerts in place, maybe you already know what's good for you, and it would be cool if you would share that, since my idea is to implement that right out of the box in Icinga for Kubernetes. And that would be my wrap-up words before we are having the beers. We can also have some questions if you like. Thank you.
Are there any questions? Yes?
How do you define thresholds for state changes?
Right now? So
right
without
now,
metrics?
and what's planned, perhaps?
So right now it's pretty easy. Kubernetes pods have phases and containers have states, and then they have reasons why they failed. And for pod states, for example, and this is, I mean, it's the smallest unit, smallest workload unit, and all the sets and deployments use all that stuff, so it makes sense to get the pod state right, and then you get all the other states right. So we go through all init containers, and if there's a failing init container, then the pod is critical, since if the init container, if there's a problem, then there's a problem. And then we go through all the containers and look whether they report problems and which problems they report. For example, if they report error image pull, so problem pulling the image, not back off, but right now then we switch it to warning, telling, okay, now we have a problem pulling the image. If it's switching to back off, crash loop back off, or image pull back off, whatever, we're switching it to critical. So we have like a mix of conditions, states, phases, reasons, grabbed out of the Kubernetes source code, what happens, or what does Kubernetes set in certain scenarios, and we use that in order to reflect it as a Icinga state. And for metrics, I would say we would somehow roll the thresholds, right, with some dices. No, maybe we have, I don't know, 9 out of 10 people use this threshold, but it would be configurable. So I would imagine that we would have the option available to use certain metrics in alerts, and then have a threshold with that, and can combine that with Icinga states. That would be the idea. But if the idea is bad, you can also say, not good.
Okay, thank you.
Are there more? Yeah. Yeah. I don't know who is first.
Can the daemon query multiple clusters, or is it one daemon per cluster?
I forgot to show a really cool thing. I'm so sorry. So, since everything is in a database and we have this cool autocomplete search bar from our PHP libraries, we can also search for everything, labels, annotations, whatever. And multi-cluster is somehow supported, since we are using for the IDs in the database, we're using the Kubernetes UIDs, so what Kubernetes generates for an object. And they will be unique, so you could have one database running, but multiple Icinga for Kubernetes daemons writing into the same database. But then, namespaces, for example, you would have a mix-up. If you kube system, for example, you would have, like, if you have 5 clusters, you have 5 kube system namespaces in that list. So there's no grouping right here. But if you know the nodes, for example, or if you have labels for your clusters, then you could go and say, okay, I only want to see pods where whatever label, I don't know, label name, K8S, whatever, K8S app. Oh, sounds good. What is that? Let's see. Sure, a K8S app. So, and if you would have a label for your cluster, you could filter it for that. That would work right now out of the box. But in the future, there's planned that we have an aggregated view of clusters as well, with metrics and little small charts and fancy stuff.
I would like to understand why some pods is marked like unknown, not critical.
Pardon? Sorry.
Some pods
Yeah.
failed, marked like unknown, not critical.
Here, depending ones?
Yes.
Yeah, it's...
No, pending, no. Was something like image pull error, or the error, I mean.
Which one?
No, there was error, something like image pull error.
This one, image pull. Yeah, no, that was an example.
No?
I don't know.
Okay.
Bad image. Image never pull, for example. This one should be critical, but it isn't.
Okay.
It's not. This will be fixed next week.
It's
Yeah,
error. Okay.
Yeah.
No.
Yeah.
I was thinking that there is some logic.
Yeah, this is a logic. This is a bug.
Okay.
Yeah. Yeah. Thanks.
There's no critical anymore. We don't want to stress out the users.
Yeah,
It's
yeah.
just
We
unknown.
only have pending since Kubernetes will do it. So yeah.
Any more questions? So I would say that's it for now.
Thank you so much.
So thank you very much, Eric.